Good afternoon, everyone. Thank you for joining us here today. Let me introduce myself. My name is Meera Vishwanathan, and I lead product strategy for the .NET team.
And I'm David Roth, and I'm the engineering manager for the .NET agent. So I guess a few ground rules. We'd really like this to be an interactive discussion if possible. So if you guys have any questions along the way, just raise your hands and we'll talk about it. All right?
All right, cool. Well, let's start off. Today we're going to be talking about the different .NET trends that have been happening in the market over the past year and a half. The journey as you transition from traditional .NET into these new trends, and how AppDynamics will help you and give you the visibility needed as you move into the new technologies. So the three trends we're going to be focusing on today are basically cloud, microservices, and the new .NET frameworks that have come out over the past year and a half, namely .NET 4.6 and .NET Core. So how many of you have some presence in the cloud right now? Well, there you go. So Gartner predicts that by 2019, 30% of the 100 largest vendors, new software investments will have shifted from cloud first to cloud only. What this means is that people are going to go from having a presence in the cloud to being cloud only. And this is further amplified by the trend of the number of people adopting Azure. If you look at Azure, Azure has grown by 102% in revenue, with their compute usage doubling year by year. Not to mention that they have over 120,000 subscriptions, new subscriptions per month, 1.4 million databases, over 1.4 million databases in SQL Azure as people move their data into the cloud, and over 40% of their revenue coming from ISVs and startups. So with all of this, obviously as you journey and transition into the cloud, there are many choices that you have to make. The first choice that you have to make is, what flavor of cloud are you going to be using? It's between private, public, and hybrid. So private is when you have an on-premise solution. You have an on-premise infrastructure, and your infrastructure is maintained, but it's not necessarily scaled, or the framework available on the public cloud is not necessarily available on-premise or on your private cloud. For public, especially with Azure, your cloud infrastructure is basically maintained by Microsoft. So all you do is you deploy your applications up there. Microsoft takes care of auto-scaling and anything that you need. However, if you have sensitive data or an app that you perhaps don't want to put up on a public cloud, what do you do in those scenarios? And this is where the hybrid cloud comes in. It's kind of the best of both worlds. So it provides a private on-premise solution with the software available on the public cloud as well. So this allows for two things. One, you can transition your software with a stopgap measure of testing it on-premise before moving it into the cloud. Not to mention, if you have certain applications that are sensitive, you can have part of it running on private, and anything that you don't mind running on public cloud can run on public, and the entire communication is very, very seamless. So now let's assume you made a choice to go with Azure with hybrid, which for Azure is basically the Azure stack. It provides an on-premise solution for Azure. On-premise or hybrid cloud solution for Azure, basically. Your next step is, what are we going to do about our deployment use cases?
Exactly. And I think the most important thing to think about when you're talking about deploying into the cloud is, where are you coming from? Because your decisions may be slightly different. There's just kind of two models. You can do the infrastructure as a service or the platform as a service. So if you go for the IaaS, then you're just basically getting a Windows VM. You can remote desktop in, you can install whatever you want system-wide, and they will manage the hardware for you in their data center. That has certain advantages. It also has certain disadvantages. The advantage is it allows you to port existing .NET applications which you may have been running in your own data center. It makes it a little bit easier because it just looks like a Windows machine. The other way is if you go all in to the app services model, where all you can do is run your application. You have no control or understanding of what's happening underneath this one application, this one like CLR essentially. So that that's the dream, right? This totally managed thing that you can just run. You don't need to worry about the hardware. It's just infinite CPU. Microsoft promise you you get what you pay for. You pay us more, you get more. Simple. The downside is you have to write your applications with this in mind. So porting an existing big monolithic traditional .NET application may not be that feasible, but if you're coming in greenfields or if you're doing a new service, that may be a better time to kind of go down this model. And again, it just purely depends on where you're coming from or where you want to go.
And of course, with all of this, so you've journeyed into, you've transitioned all your apps into the cloud, but you want to be able to see visibility. As you're moving this, you want to make sure that any problems that come up, you are ahead of it. And this is where AppDynamics comes in. So when we chose to monitor Azure with AppDynamics, there were two main use cases we had to solve. One, how do we monitor it? Because there are some fundamental architectural changes that need to be made. And how do we deploy it? So I'm going to transition over to Dave to kind of go over the architectural decisions that we made while we moved into supporting Azure PaaS.
Okay, so when we put the deep dive on this slide, I kind of took them at their word, and so we're going to do a real deep dive. And what I wanted to talk about is a little bit of how our agent works and also how just profiling within .NET works. And then I wanted to highlight the differences between a traditional classic IAS install versus the changes we had to make to our agent to work within the PaaS infrastructure. Some of it totally not relevant to you unless you're writing a profiling tool and it's just a FYI, but some of it is relevant because these are the kind of decisions and trade-offs you have to make when porting an application into a PaaS-based environment. So this is my appalling diagram, but I'm not an artist. Oh shit. Here we go. So this is just a traditional CLR process. So there's kind of two main components when you're instrumenting or profiling a CLR process. One is the profiler, which is Microsoft's iCore profiler interface, which they give us. And this is written in C++ and gives you the real low-level callback. So if a class loaded, class unloaded, JIT about to happen. So we monitor the CLR internals with this, and that allows us to do our IL transformation and things like that, and actually our sampling as well. You have one profiler per CLR process. The second part is the app domains. So this is where your application code actually runs. So Microsoft, as you probably know, made it very flexible how you deploy .NET applications. You can actually host multiple applications within one CLR process, and each of them are totally separated. There is no communication between app domain 1 and app domain 2 by default. There's also another app domain called the shared domain. So when you install a Windows assembly into the GAC on the system level install, the assembly will get loaded into the shared app domain, and then the kind of user app domains can reference the shared domain. You can't go the other way around. And that was the first problem that we had when we were porting the agent to web apps. We don't have the ability to install our assemblies into the GAC. So when we deploy a web app with the agent, we have to have our assemblies installed along with your application. So because of that, the whole security model had to change, and we had to do a bunch of very low-level hacks to make this work. No, not even hacks. We had to re-architect so that we could run outside of the shared domain and entirely within the app domain. So that was the big one that had some significant knock-on effects on the profiler too. The second part is, as I'm sure you're aware if you're an existing customer, we have a Windows service that we call the coordinator. And this guy kind of does double duty. One, it runs with elevated permissions, so it can read things that we may not necessarily have permission to do in the lower rights of a worker process, so reading certain machine level perf counters, that kind of stuff. It also, there's an IPC channel between the coordinator service and all the worker processes where we do some config and kind of housekeeping things. Again, in Azure, in web apps specifically, we can't run on a Windows service. So we had to refactor and kind of rejig how we're getting that information and basically be more robust about working standalone without a coordinator service. So we did a first step to make this work, but this is not done. This is one of the things we want to do going forward is focus more on decoupling the dependency on the coordinator with the agent. So if you choose to not do a site-wide install, you can just run just within your application. So yeah, I guess just to summarize, the kind of things you'll probably see. No Windows services, no installation into the GAC, and you're running with a reduced permission set. For example, we can't get you machine level performance counters like CPU metrics. But if you think about it, that's the beauty of these PaaS solutions is you shouldn't care about what the CPU is doing on the machine. You can't know that. So that's where you get the advantages there. All right, next.
And so the next level of choices that we had to make is how do we deploy it? So again, we're going to, as a common trend, we're going to go between Azure Infrastructure as a Service and Azure PaaS. So in Infrastructure as a Service, you had the full solution, you have access to the machine, so our regular MSI worked just fine. But we wanted to give you a good deployment strategy to be able to move your agent into Infrastructure as a Service. And we found that a lot of people were using NuGet. So we basically packaged our MSI into a NuGet package with a few additional scripts, which automate the deployment. So as soon as you move your NuGet package, install your NuGet package into your application and move it into Infrastructure as a Service, the agent comes installed. Then came Azure PaaS. Now Azure PaaS has a few more options. So the first option we picked was, of course, making sure that we kept in line with the development story and had a NuGet package as well. And it works the same way, and we will be doing a demo of that a little bit later. But we also understood that some people may not want to access the Visual Studio environment. Some people may not want to have NuGet installed in their system. So we decided that on our roadmap, we're going to have site extensions. What it allows you to do is have a side-by-side install of your agent with the AppDynamics, of your application with the AppDynamics agents installed in it. And the way it works is that you can use an ARM template, which integrates very well with Azure Stack or a lot of Microsoft's deployment solutions. You specify your website, and you specify the application, the AppDynamics agent or the AppDynamics site extension that you want added to it. Once you do that, AppDynamics comes pre-installed, and you don't have to do anything about it anymore. So that being said, so let's kind of talk about our customer story. This is a fake customer, and they have something on-premise, something on Infrastructure as a Service, and something on PaaS. And this is the kind of flow map we want to be able to provide you. And with our current solution, this is the kind of flow map that we strive to provide you as well. If you take a look at it, this is an on-premise solution. This is an Infrastructure as a Service solution. It talks to Azure, an Azure web app. This is the Azure web app right there, which has a call to a database, an async call to a database. And we also support, as part of the Azure App Service, not just Azure Web Apps, but Azure API apps as well. So if you look over here, both the Azure front-end application makes calls to a list API, to 2 Azure API solutions. And all of this is monitored out of the box. And that's kind of our main focus, to make sure that your deployment process is as seamless as possible. So before, during, and post-migration, AppDynamics will help you be ahead of any issues you may encounter. So I'm going to run and do a demo, but we're happy to field some questions while we get the demo up and running.
Something about profiling, how it works, deployment, any issues you guys have run into if you've already been through all this. All right, cool. In which case we'll move on.
Yes.
Oh, here we go.
So when it comes to migrating to Azure, Microsoft has their application insights monitoring tool, and in a lot of cases, like in ours, we're kind of being told, well, Microsoft already has this solution, we're going to use that. So what's the differences there?
I will let the PM side handle that one.
Of course. So Application Insights is a wonderful tool, absolutely. What AppDynamics offers for you is transitions not just within .NET. So if you have an application in Java, you have an application in Node.js, you have an application in PHP, you want analytics, EUM, or server infrastructure monitoring for your application, that's where we come. We provide you full end-to-end correlation, not just within Azure, but across the board, regardless of the choice of technology that you make. Of course, provided that we support the technologies, but that's kind of the story that we try to tell, which is we want to make sure that your correlation is not just within a certain infrastructure, but across the board.
And I will also add that App Insights, yes, is there, it's a tool, But Microsoft is trying to develop an open platform, and we are working with them and the other vendors to ensure everyone's APM tools works within their, because this is not the Microsoft of old. They want an open ecosystem where people can use the tools that they need to use within their environment, because it's not a homogeneous environment anymore. People have a little bit of everything, and they need to play nicely within that, and they do.
All right. Well, we're going to do an out-of-the-box Azure application and just show you how we monitor it. But before that, does anyone have any other questions? Great. Awesome. So I just created a new project. It's an ASP.NET MVC web application. And we're going to be installing the AppDynamics Azure agent into it. So what you do is you press the install button, wait, run through basically just saying, I accept my license agreements. And this is where we kind of come up with the little the controller box. You have to just enter your controller credentials into it. And I have that saved, thankfully. So I'm going to
We don't usually recommend you store your credentials in clear text files, but for the sake of the demo, Amira, you do know everyone knows your password now, right?
And apply. So this basically installed the NuGet package into our solution. What we would like to highlight is a few things. So one is that we have an XDT file that comes packaged in. What this allows is two deployment strategies when you move your application into the cloud. The first is with the XDT file, it basically sets up all the environment variables that you need. So you don't actually have to go to the portal and enter those values manually. However, if it's a solution that you would like to do, because some people have automated solutions for entering those environment variables, we do provide that option as well. So you can go in, enter the environment variables, restart your application, and AppDynamics is there to give you the full visibility.
Yeah, exactly. I mean, I think our bottom line is, almost slipped there. Our bottom line is we want to work as seamlessly as possible within your environment. So we don't want to put you down the path of this is how you have to deploy. We need to be flexible, working in all these different deployment models.
So I'm going to run through a quick web application, and for the sake of time, we'll keep the really awful name that's been selected here. Create the deployment. And this entire process is also exactly how you would just normally publish a web application to Azure. And publish. Great. So once you do that, and we'll just wait for the publish to happen, what happens is you go to your Azure portal, and under App Services, you'll see the new app that has been created. So in my case, it's this app right here. What we do require at this moment is you do have to go and copy the XDT file up one folder, which we are planning to change with the implementation of site extensions. Can you explain why we need that modification, why we need to move the XDT file, and why site extensions would help with not needing that manual step anymore?
Well, again, it's just another a flavor, because when you burn yourself into an ARM, it automatically goes, Microsoft behind the hoods will copy a lot of this stuff in automatically. The XDT file is a slightly different model where, as Mira said, it allows you to predefine an environment through a text file, so it's somewhat automated and it goes along with the application. There's another model where within the front end there, you can manually specify the environment variables. And again, I have a natural distaste for environment variables, but there's certain places where they're needed, and specifically the core profiler ones, that's just how you do it. So that's how we...
Well, it looks like we have some connectivity issues here.
Oh, really?
Yes, unfortunately. But what effectively happens, I can actually take you through another app service I have running. If you look at the AppSphere Azure front end, and I go to Advanced Tools, what I do in Advanced Tools is click OK. When it's the Kudu console that comes built in with Microsoft Azure, so there's no customizations there. And it's still taking some time. You know what? I'll maybe come back to this once this loads a little bit. So in the meantime, we'll go back to the presentation. So what we are strive to offer you is easy and flexible deployment, whether you're using Visual Studio's Team Services, whether you want to use site extensions, whether you want to use Azure Stack with the Azure Stack with the ARM templates. We provide you with a flexible and easy deployment. Everything's out of the box, so there's no configuration that's required, no manual configuration that's required. We work across public, private, and hybrid cloud. We provide full end-to-end correlation across the applications, whether it's on-premise or on the cloud. And we also monitor deployment slots, so if you are switching from staging to prod, we offer full support and full visibility into that as well. So that being said, let's talk about the most exciting thing, our roadmap. So what we currently offer is we support Azure Virtual Machines, cloud services, app services, and exit call detection to SQL, blobs, tables, storage, and queues. What's coming down the pipeline are two things. One is Azure Service Fabric. So we do allow monitoring. We already monitor the application that runs on Service Fabric. What we are working to improve is the deployment process of monitoring Service Fabric. Additionally, with Azure App Service, Web Jobs is coming down the pipeline, and as we mentioned before, site extensions is coming down the pipeline as well. So this kind of covers Azure, and let's backtrack a little bit over here and say, you chose to create a new application, a brand new application. So when you're choosing to create the brand new application moving into the cloud or brand new application on an Azure infrastructure as a service, you're likely to use the new .NET frameworks that came out, namely .NET 4.6 or .NET Core. So let's talk about the next generation of .NET and what AppDynamics is doing to support that. So there are two frameworks, the .NET Core and .NET 4.6. And what's new in that is it allows for portability. It allows you to host your website on IIS, Kestrel, a web server they've created, or Owen. And deployment allows for NuGet deployment, or it supports in-app and side-by-side installs as well. And a lot of it is command line. So that being said, what we wanted to do is say, how do we go towards supporting this entire structure? The first thing we did was say, let's support .NET 4.6 and the Owen architecture that comes out of .NET 4.6. So Owen is basically a middleware. It's a middleware that allows you to host your application on Owen, which allows easy portability across applications. So if you want to self-host your application or host it on IIS, Owen allows you to gain that easy portability. So that being said, so the two use cases we were thinking about is self-hosted or IIS, as we specifically mentioned. So these are the two areas that we wanted to focus on, especially with Web API, because that's kind of where we see a lot of Owen use cases coming from. So we're actually going to go back into doing a demo for Owen to kind of show you the information that we have. But it looks like in the meantime, our app service actually did get deployed. So we'll backtrack a little bit, show what happens to the app service, and then jump directly to Owen. All right. Awesome. So if you go in here, you see this is the Kudu service. You go into your command line in Kudu service, and I do apologize for the connectivity issues. Oh. Okay.
Wow.
Another small move, apparently.
Yes, and I'm sure anyone who's used Azure, this is it's usually more performant than this. I think the problem is at our end.
Perfect. So we're going to start off with Owen. So I'm going to let you speak to the application and.
Sure. So I think the really interesting thing about Owen and why it's being done is Microsoft are decoupling the application from IIS and all those dependencies. As when you wrote your traditional ASP.NET or whatever application, you were hosting it in IIS, you had all those classes, and that is very good in certain circumstances because IIS is actually pretty good and you can get a lot of features from it, but it doesn't work for everyone. And a lot of other languages, and you have more flexibility in deploying it because Sometimes you just want to have a standalone application that can host HTTP connections, and run that way. So that's what Owen provides, is the flexibility. And so here you can see a self-hosting Owen application, and it is just an application. Here's your main function. Sorry? This,
Zoom in.
oh, sorry. Oh, where am I going?
Oh, right there?
I got you.
Yeah.
Let's go for 400. Oh, that's yeah, a little bit crazy. Can you guys see that? Yeah, it's too big. No, let's find the sweet spot. 200, there we go.
There you go.
Perfect. Yeah. So here, this is your standard main function. You just use web app start, new HTTP client, and then you've got your loop listening on the request. So if anyone has ever used any other frameworks, to me, this looks just like a Node.js application. Again, it's a super simple thing. You just make a couple of calls, and suddenly you've got this process that's handling HTTP requests. And that is the beauty of Owen. So now if we compile this and run this, we can instrument it just like any other IIS application.
Mm-hmm. So if we were to move on to the controller, we can actually show you the snapshots that you see and the information that you will get.
Which you will have.
So right here.
This guy?
So let's go back into applications.
Perfect. So
And
where are we going?
the infrastructure as a service app right there.
Here we go.
Yeah.
So this is multiple tiers again, talking with all the different flavors. But this is the Owen self-hosted application tier, which I just showed you the code of. Super simple. So one of the big differences is because AppD as a whole across all the language agents, we understand frameworks. That's what we do. We understand what an ASP.NET call looks like. We understand what a WCF call looks like. When we went to Owen, it is a new framework. It's totally different to IIS.NET applications. So when we were added support for Owen, that was what a lot of it was refactoring to kind of the refactoring that Microsoft did to create Owen. We had to do similar things to remove dependencies on certain classes and certain assumptions. So now we have a better factor thing. So that's one thing you will notice if you look at the call graph on a Owen self-hosted call is you have the entry point looks different than your traditional ASP.NET application. So I don't know if you guys can see that. You'll see this is not your traditional ASP.NET. And then if you go to
You just have to drill down to the call.
Yeah, drill down to this guy. Yep. You will see here, again, this is another entry point. So this is just to show that it's different, but we handle all these different frameworks. And as and when things change, we will add support for them.
Yep. So there you go. So that being said, so we just went through the demo. Again, our big option was to say, we want to make sure this is all out of the box, so there's no configuration that you have to do in order to support this. We also wanted to provide full, complete snapshots. So any Owen application has full, complete snapshots, and you can identify issues, be ahead of it as soon as you move your application into using the new .NET frameworks. In addition, we have end-to-end correlation and NuGet package support because if you used it with Azure, you'd be using it with NuGet or site extensions when. So that being said, this moves me into my product strategy, which is where I get super passionate. So the major things that we see, if we had to tie it back to the original trends that we were talking about, which is cloud, microservices, and the new .NET frameworks, it kind of came down to patterns that we were looking at. So Owen provides us the perfect framework to kind of start thinking about how we want to support portability. And the major things that we're thinking about is .NET Core and standalone installations. The reason being that .NET Core obviously allows for portability, allows you to run your application on IIS or off IIS on a Kestrel web server. And with standalone installations, what we discovered is with portable applications, we wanted to give you the flexibility to say, I want to monitor just the app, or I want to have a system-wide installation where I monitor not just the application, but the machine itself. So that's kind of where our product strategy comes in line with where things are going. And of course, we're continually looking to improve our deployment and cloud and microservices with our roadmap and where we're going. Sorry. So that being, sorry, go ahead.
No.
So that being said, what I want to say is it's important to us that we journey with you as you move and transition.
Sorry?
You know, connecting.
I'm
Connecting to the internet.
Oh, no, we're
no,
good.
that's
We got
okay.
it. Thanks.
Don't worry about it. So what we wanted to say is it's important to us to be on the journey with you as you transition into your new applications. We want to make it painless. We want to make sure you have full visibility so you can be ahead of any issue that you find. We want to give you a seamless and painless transition, and that's why the deployment strategy was super important. And we want to give you full stack visibility, which we're trying to gain with all of the new .NET frameworks that we're trying to support. So that being said, visibility before, during, and post-transition is our key strategy. Thank you. Are there any questions we can answer?
Shoot. Yeah, yeah.
You mentioned, of course, under PaaS, you don't have access to quite the same breadth of counters. For example, you don't have a CPU counter. Is there some equivalent thing, though, that will let you realize that your app is starved for resource and processing?
Not really. And again, that's by design because the promise is that you paid for the resources, you get those resources, and your failure mode should not be because of resource starvation. So there are certain higher level Azure level metrics that we're building extensions around, which will kind of show you that. But honestly, if all things are working as promised, that should never be the problem.
Yes, please. So there is a way to monitor Service Fabric right now that's kind of in the labs for AppDynamics. So we do monitor the application that runs on Service Fabric. We monitor that entirely. Not to mention that Service Fabric actually runs on the Azure VM. So courtesy of that, we do monitor it. Where we are trying to improve it is basically our deployment strategy. So do we monitor it right now? Yes. Is deployment as seamless as it is for the rest of Azure? We're still working on that. Yeah. Any other questions? Yes, please. I'm sorry?
What is the licensing model for the PaaS?
Yes. So an instance of a web app counts as one license. Yes, please. Sorry, sysinternals? Yeah, of course. Right. So at the moment, what we do offer is something called machine snapshots. So if you go into the machine snapshots, you actually do get information about the processes that are currently running on the system in the window that the machine snapshot was sent during. All of the IIS app pools and the queue length of the app pools and any extra information. So if there's something more that you want to see, please let us know and we'll work towards incorporating that.
Correct, but just to clarify, the machine snapshots do not work in PaaS.
Yes.
We just can't do it.
We just can't do it. Yes, please. Mm-hmm.
But if you're going really towards IAM, because you have a big application trying to get out there. So what's the deployment for that? Is it just sort of like we're on-prem, deploying agents?
Yep.
Well, within that environment, and that's more towards the Azure VM model, is like, you know, if your application is used to running on a full Windows machine and maybe you have some Windows services, you can still do that, and that's why they keep the Azure VMs, which is a totally legitimate way to do things. I mean, not all applications work well within this PaaS environment, you know, but so I don't think Microsoft is pushing you towards you have to develop apps like this. It's just another tool that you can use when it makes sense.
Yes? So we do support exit calls into Service Bus. We have extensions that allow you to see more information about Service Bus and metrics within Service Bus. But in terms of agent functionality, yeah, we support exit calls, so we support the correlation through the Service Bus. Yeah. Any other questions? Great. Well, thank you very much for joining us today.
Thanks, everyone.